Hey guys, today's lesson is going to start with a little bit of a review. We're going to go back and talk about circles. And the reason why is we're actually going to use a similar strategy to a problem we're going to do here on our today's homework when we talk about parabolas. So recall that circles and parabolas are in the same family of shapes that's called the conic sections. And there's four shapes in the conic sections. There's the circle and the parabola, which we study in SM2. And then there's a hyperbola and ellipse, which you'll study in SM3 or 1050 after that. So we're focusing on the circle and the parabola in this unit in SM2. We were talking about parabolas yesterday. We're going to kind of come back to circles for just a second. We're going to circle back. Get it? Circle back. Talk about circles, and then we're going to talk about parabolas again. Okay? So just as a refresher, this right here is called the standard equation of a circle. So right before spring break, we talked about circles, we talked about how to write an equation for a circle. They're not a function, because if you think about it, if you were to graph a circle, it's not going to pass the vertical line test, so it's not a function. But there is a way to write an equation for it, and this is it right here, right? Remember that the h and the k are the center of the circle, and then the r is the radius of the circle. So that's kind of what we got going on here. This is we'll call the standard form or the standard equation of a circle. This is just a specific example of that. So if you look at this equation, oh, forgot to square it, sorry. Been working with parabolas too much. Okay, circles have two square pieces. We're going to have this piece right here will tell us the x-coordinate of our vertex, center, because we're talking about circles, is going to be 3, and then the y-coordinate of our center is going to be -2. So it's kind of similar to the equation we've been working with parabolas, but this is, again, for a circle. The radius here would be 5 because this is r squared. So if you take the square root of that number, you get a radius of 5. So that's just a review. How to find the center and the radius. Okay. Notice finding the center of a circle is very similar to finding the vertex of a parabola when you have a form like this. Now this is what I really wanted to review because we're going to use a similar strategy to this today when we talk about parabolas. So come back, review the circle part, and then we'll move on to parabolas. So this right here is not in standard form, or it's not a standard equation for a circle. It is the equation for a circle, but we just don't know what that circle is yet because it's not in this form. So our goal is to put this guy into this form. That's what we want this to look like. Okay? We talked about how to do that, so let's review. What we're going to do is we're going to use a strategy called completing the square, and we're going to do that twice, once for the x variables and once for the y variables. So I'm going to rewrite this. X squared minus 6x. So notice that I took the x squared and the minus 6x and took those first. And then I'm going to leave a space because that's what we're going to use to complete the square. Then I'm going to write the y stuff. So after that, I'm going to have a plus y squared plus 8y. And then I'm going to leave another space right there. And then I'm going to have an equals 0. So this and this are equivalent. I just have rearranged some terms and created some space for myself. Okay, now what we're going to do is we're going to complete the square. We're going to find out what number has to go here to make this a perfect squares trinomial, which we also talked about factoring earlier this week in our factoring practice. So to find out that number, we take this number and we divide it by 2, which is going to give us a 3, and then we square it. So this is going to be -3 squared. So -6 divided by 2, whatever that gives us, we square it, and that's what's going to go right here. So this is going to be a -3 squared, which is a +9. Okay? Now because I added 9 here, I also have to add a 9 on the right side. I'm going to get rid of this for just a sec. All right, now over here, we're going to do the same thing. We're going to take the middle term, the coefficient of the middle term, divide it by 2, that's going to give us 4, and then we square it. So 8 divided by 2, whatever that gives us, we take that answer and we square it. Right? Well, that's going to be 4 squared, which is 16. So plus 16 on both sides because we got to keep this guy even, right? Okay. So now what I'm going to do, now that these are perfect squares trinomials, which is exactly what I wanted to do, I can now factor these perfect squares trinomials. I know what they're going to factor to. They're going to factor to x minus 3 squared and y plus 4 squared. Okay, how did I get that? Well, recall that to get this number here, you take this number just divided by 2, right? So take this number divided by 2, we get our negative 3. That's what's going to go inside these parentheses. When we square that number, we get this guy over here. That's the same relationship here, right? Take this guy divided by 2, you get a 4. Take that 4 and square it, that's the number that goes over here in the back. That's the relationship that we have when we talk about these perfect squares trinomials. So we force these to be perfect squares trinomials so that we can factor them to binomials squared. And since we've practiced that this week with the factoring worksheet, hopefully that's a little bit clearer for you. Okay? On the right-hand side, we have equals 25, because 0 plus 9 plus 16 is 25. Right? Awesome. So that's our standard equation of a circle. We got it. So this guy is centered at 3, negative 4, and it has a radius of 5. So it's similar to this one. I didn't mean that to happen. It's just kind of a coincidence that it came out that way. But if we wanted to know the center of this circle, write it over here. The center would be at 3, negative 4, and then the radius is 5. So if we want to put a conic, like a circle, into like standard form or give a standard equation for it, completing the square is the technique that we use to get it in forms that look like this. So I wanted to review that idea, that complete the square idea, changing forms of an equation, because we're going to do that with parabolas in this lesson today as well. So hope that kind of brushes the dust off of that concept and rings some bells for you. We're going to come back and do parabolas in just a few minutes.